Hi everyone, welcome back to the channel. Today we are going to discuss Anova in R. In the previous video, we talked about t-test which compares two groups to test whether they are significantly different or not. Whereas Anova is used when we have more than two groups for comparison. Also, t-test makes a comparison by analyzing the means of two groups, whereas Anova analyzes variance as a tool for comparison. So let's go to R. First, we will import the dataset empty cars. To perform Anova, we use the function AOV and we mention the two groups like we did in t-test. In t-test, we were basically using the sign empty cars dollar column name, but here I'm going to just mention the column names and then I'm going to mention in the second argument data, that is empty cars. I'm also going to assign a variable to the Anova that I will do. So afterwards, I can take a summary of this test. So I'm going to perform a one-way ANOVA. What is one-way ANOVA? In one-way ANOVA, we take different groups belonging to one category. For example, in this case, I have taken CYL, which has three values, 4, 6, and 8. And accordingly, it will divide WT column into three groups. So I will perform this. And these are the results that I will get. Column headings are DA, that stands for degree of freedom, sum squares, that stand for sum of squares, mean squares, that stand for mean of the sum of squares, F value, that is calculated for ANOVA, and the P value that corresponds to the F value. The results of the first row corresponds to between group results, whereas the second row, that is residuals, corresponds to within groups. Now, if you can see CYL, the degrees of freedom states it is 1, whereas we actually know that degrees of freedom should be 2 since we have three groups. Know that actually it is not taking all the degrees of freedom because it is not taking CYL as a factor. So we will actually change it and we will make it as a factor. And then we are going to run this test again. Now here you can see the degrees of freedom has become 2, which was originally meant to be. If you want to know more about these things, I've already discussed ANOVA in detail in my previous video. I will also provide a link in the description below. So here you can see the p-value says that the difference between the groups is significant. But which group is significant and which is not? How can we say that? To find out which group is significant, we do a post-hoc test. In this case, we are going to run Tukey test by using the function Tukey HST. And we are going to run it on the variable one way because ANOVA results are stored in the variable one way. So let's run this and see. You get the post-hoc test. So Tukey test will give group-wise comparison. As I've said before, CYL has three values, 6, 4, and 8. So first row shows the comparison of 6 to 4, second 8 to 4, and third row shows the comparison between 8 to 6 group. The DIFF is actually the difference in the means of the two groups, whereas LWR and UPR are actually the lower and upper limits of the confidence level. And at the end column is p-value. So this is for one-way test. Now let's go to two-way ANOVA. It basically uses two categories. Previously in one-way ANOVA, we were only using CYL, that is one category which was dividing W2 into three groups. But here we are going to take two categories, AM and CYL. I'm again going to use AOV function, but when I'm going to mention the column names, I'm going to mention WT against two columns, and I will use plus sign to tell that two columns are being used. So I will store the results of ANOVA in two-way variable and take a summary of this. So again, you can see those are the same results. One is for AM category and the other for CYL category. But the degrees of freedom that are being taken is again 1 and 1. So again, I have to add factor to it. So there is an easy way where I can turn all the columns that I want as a fact, which I have browsed from the internet. Every good programmer has to do it once in a while. Let's paste it here. And let's run this command. Now, when I'm going to run the two-way ANOVA, I will get that AM has two groups 0 and 1, so the degrees of freedom is 1, and CYL has three groups, so the degree of freedom is 2. So again, we are getting all the values like in one-way ANOVA. But as previously, we have to use a post-hoc test. So let's run Tukey HST function on two-way ANOVA results. And here we are getting the post-hoc test results. So as I said, in category AM, there are only two groups 1 and 0. So it is giving the comparison of 1 and 0 group. And again in CYL there are three groups 6, 4 and 8, and it is giving a group wise comparison between all of them. But there is another way of doing two-way ANOVA here. That is use two-way ANOVA with interaction between two categories. And to do that, I have to replace plus sign with the asterisk sign. And I will store the ANOVA results in two-way underscore with, that means with interaction, and I will run the summary on this ANOVA function. And see, now before you were getting only three rows, one for AM, one for CYL, one for residuals. Now you will be also getting one extra row for AM colon CYL that describes the relationship of the two categories. So if I run the Tukey post-hoc test on this, so first thing we will get is within AM category, we have two groups 1 and 0, and we will get a comparison for that. Within CYL, there are three groups, they will be pairwise comparison for that. But then there is AM colon CYL. So here what they will take is, they will take every combination of AM and CYL and compare it pairwise. For example, in the first row, this is 1 colon 4. That means group 1 of AM and group 4 of CYL is then compared group 0 of 4 and colon group 4 of CYL. That is all for today. Thanks for watching. If you learned something from the video, please like, share and subscribe the channel.